In this video, I'm going to show you how to calculate bulk unit weight, dry unit weight, and effective unit weight of soil sample using Python with a library called groundhog. Groundhog is a library or a Python library that you can easily use to verify some of your soil mechanics and geotechnical calculations. So let's dive in. Okay, the first thing we need to do is to install the library using the pip command. So after we've installed it, then the question now we are solving is this. So we are supposed to calculate the bulk unit weight, dry unit weight, and the effective unit weight of the soil. So given all this data now, as you can see, we have extracted the data from the question. We have the weight of the sample, the weight of the water, weight of soil, weight of container, the unit weight of water, and then the specific gravity. So the saturation is 1. Yes. Then, as you can also see, we need to show that actually from this we were able to see that the saturation was 1 since the soil was fully saturated. So we need to compute the water content, and that's the formula in which we are going to use the weight of the water, which is 1 Newton, weight of the soil is 4, 1 divided by 4 times 100 is 25%. Then from here also we need to calculate the void ratio, and that's the formula for computing the void ratio. So when you put all the necessary parameters, you are going, and then for the bulk unit weight also, so the dry unit weight is also there, so the effective unit weight is also computed. Now we are going to implement it using the groundhog Python library. So we are now importing all the necessary functions from the library, and that's the documentation of the library. So as you can see, the bulk unit weight function is there, which takes about 4 parameters there, and we are specifying it. Also, we need to be able to show you how the dry unit is going to be calculated using the dry unit water content function, in which it takes 2 parameters. Then from here we need to run the code here, this cell, and then we are defining all the variables from the data given in the question. We are putting them as variable in this cell. So we are going to run the cell now. Then we are now doing the actual computation by passing the necessary parameters to the function that we have imported recently. So this is the saturation, this is the arguments which represent saturation, the void ratio that was calculated, that's for saturation, and then that's for the void ratio. So this is for specific gravity, which we have defined as 2.7, but we can actually change the 2.7 to the variable that we have defined. Yes. So in the unit weight of water also. We define it. Then we all know that from the documentation, it takes into from the documentation we are passing the saturation and the other parameters to it. So we are changing the unit weight because the default is 10, but we are using 9.8. So from here now, we need to, it's going to return to us the answer as a dictionary. So from here we are going to run the cell. So this is the dictionary of the results we are getting, which is inconsistent with the answer that we have computed manually. So we have computed the dry unit weight, the effective unit weight, which is 9.9, and then the bulk unit weight, which is 19.9. So for the dry unit weight now, we need to do the calculation, and we are going to run this function. So dry unit weight is 15, which is also inconsistent with the result that we have gotten.